So let's talk about the derivation of the parabola locus formula. So we're going to use the locus definition of the parabola to derive the equation of the parabola whose vertex is right here at the origin, 0, 0. So this formula that we're using, y is equal to 1 over 4p x squared, we're going to talk about how we got to that so that you can trust it. I'm sure you trust it already because, your teacher gave it to you, but you need to understand how it works. So let's look at what we have here. We have the focus is 0p. The vertex is at the origin. The directrix is the line on the y-axis, the horizontal line here, y is equal to negative p, where the distance from the vertex to the focus and the distance from the vertex to the directrix, that's going to be congruent. These are the same distances here, okay? So we can, work out any of these other problems that we have the same way if we wanted to. But doing it like this, using this derived formula is going to help you to solve it much faster, as we've seen in the past problems that we've just done. So the vertical distance here, d1, from xy on the parabola to the directrix y is equal to negative p, which I have here as the point x, negative p, because it goes to the x point here and comes down to the negative p, which is the directrix y is equal to negative p. So it makes sense that the y value for this point here is going to be the x negative p value. Okay. And that is the distance from the x-axis to xy, which is y, plus the distance from the x-axis to y equals negative p. So you have this y value here, and then you have this value here, which is p, right? It is the distance between here and here. So the distance 1 is equal to the y value from x, so the height here, and the distance, the absolute value from x to negative p. So distance 1 is going to be equal to y plus p. That should make sense. This is your y value right here. Tells you how tall, how many units this is. Does that make sense? So y and p is going to be the distance of distance 1. Okay, so then we use the distance formula to get the distance from xy to the focus, OP. And this is what we find. We get distance 2 is equal to, we're going to use the distance formula, we get x squared plus y minus p squared. That's how we're going to use the distance formula here. Because x and 0, that's going to be x. So x squared. X minus 0, which is what this would typically be, would just be, let me redo this so you can see where I got x squared from. If we were to do x minus 0, right, squared, x minus 0 is just x. So we can just write this as x squared. And then we're going to add that to what we usually do, which is y minus p, or y minus whatever that number is here, and square it. So that's our distance formula for 2. So since we know that this distance is congruent to this distance, we can set them equal. d1 is equal to d2. So we can say y plus p is equal to the square root of x squared plus y minus p squared. Now we can just solve it. So the first thing we're going to do is we are going to square everything to get rid of the radical. So when we square this side, we get y squared plus 2py plus p squared. And when we square this side, we just get rid of the radical symbol. So x squared plus y minus p squared. Now we can square this since it's got the exponent on it. So we get y squared plus 2py plus p squared is equal to x squared. And then this is plus y squared minus 2py plus p squared. All right, so now that we've got all our distribution, we can combine like terms by moving things from one side to the other, by swimming our little fish, right? So if I subtract y squared from both sides, that cancels the y squared. If I subtract p squared from both sides, that cancels the p squared, right? So now I'm left with 2py is equal to x squared minus 2py. So I'm going to add 2py to both sides. So now what I end up with is 4py is equal to x squared. Well, guess what? I want to have y by itself, right? That is how we write functions, is with y by itself. So I'm going to divide both sides by 4p. So y is equal to 1 over 4p times x squared, which is the same thing we have up here. That's how we get it. That's how we solve it. And that's how we know it is the accurate formula. That is your proof to understand where the formula comes from. So we were going to have a couple of practice problems. You're going to be asked to solve some things that we've covered in this derivation, in the application, in the other two sections, A and B. And they're all kind of related, so it's okay. You're just going to have more of the same practice problems. And that's all we have for Lesson 68. I'll see you in Lesson 69.